Oh, I forgot we're on a web page for our code. Okay, so we're going to do binary to 2's complement here. Well, after we read in our answer, or read in our value rather, we need to ask the question if this guy's a negative number or not. So we know whether or not we need to pass it through our 2's complement or not. So we're going to say if value is less than 0. If they gave us a value that's less than 0, then we're going to go ahead and I guess we can do it all inside this one if statement. So if it's a negative number, the very first thing we're going to do is we're going to say value is equal to value times -1. Let's get it to the positive number version of itself. All right. Then we'll go ahead and get the decimal, the binary version of that rather. Okay. I'll go ahead and throw my else in here. We can write this a little shorter, but I'll just be explicit. Otherwise, it must be a positive number. So I'll go ahead and do my thing there. And print it out. So that's all we'll do for positive numbers. Convert it to binary, print out the answer. It's for negative numbers that we need to encode in 2's complement. All right, so we have the number here. Now we need to get it into 2's complement. So 2's complement says flip all the bits and then add 1 to it. So we need to do some math in here as well, right? Okay, so first we got to go through and we got to flip all the bits. So let's do that. We decided we're probably going to store this in a new array. So I'll go ahead and I'll just create a brand new integer array of the same size in bits, and then we'll just go through and copy the inverse of everything through. So we'll go ahead and we're going to say int array answer is equal to malloc bits. So we'll create some memory, bit sizes of memory. All right. Then we're going to have our int I for I is equal to 0. I is less than. We know this guy is stored as a Oh, actually, we don't need to worry about that because they're stored as integers, and we saw we didn't need to use the size of thing. So I is less than bits, I plus plus. All right, so we're going to be copying the current value into answer at the same position, but flipping the bit. So a 1 becomes a 0, and a 0 becomes a 1. We could do an inline if statement if we wanted to here, but I'll just write it as a longer if statement. So we'll go ahead and say,
Can you do a swap?
Well, you wouldn't do a swap. See, 1. You could possibly say you could do the absolute value of the value minus 1. So 1 minus 1 is 0, absolute value of 0 is 0. 0 minus 1 is -1, absolute value of that is 1. So if you really didn't want to do an if statement, you could. That would actually be kind of funky code to follow because it would look kind of weird. But the math would work. But I'm just going to ask the question, if the value at AR plus I is equal to a 1, we'll say the value at answer plus I gets 0, else answer plus I gets 1. Like that. So go through all the bits. If the current bit we're looking at in AR is a 1, store a 0 in answer. Otherwise, store a 1 in answer. All right, so that will flip all the bits. So this guy will do the ones complement. All right, so now we need to do the twos. Who? For what? Oh, for the twos complement? Oh, yeah. But so's they'll do the same thing. But this is pretty clear what we're doing, right? This reads pretty simply. Yeah, he's saying this is the truth table for XOR. If we use a bitwise, just show that real quick, because that's something else we're going to be dealing with. We saw in the assembly language stuff earlier that there's left shifts and right shifts, things like that. So we have bitwise, something called Bitwise Operations. So if we have 1 XOR 0, so 1 or 0 but not both. So a 1 XOR is going to be a, and then a 0 XOR 1. Actually, this won't be, this is still a 1.
1 becomes 0.
Well, right, but what are you XORing together?
You will XOR 1 with that 1.
Well, so if I'm
each number with 1, so it automatically flips 1 with 0, 0 with 1.
Flip back and forth.
Oh, you assume there's a 1. So you'll do this. You'll XOR whatever value is currently there. You're gonna.
With 1.
So if I have a value that's like this, if I have a value that looks like 101, and I'm flipping this, so the first thing I'm looking at here is this 1. So I would say the 1 XORed with 1 would be a 0, like that. If I was looking at the 0, I would say 0 XOR with 1 will be a 1. So you're taking this and always XORing it against the 1 as the constant. Yeah. Okay. So now the twos complement is we're going to add a 1 to this guy. So now we have to do our binary math. So we're going to start at the very end of this guy. We're going to have to deal with a carry bit, right? Now, we could, if we wanted to be sloppy, we could cheat. We can turn this guy back into a decimal, add 1 to it, then turn it back into a binary number. But that's not fun. We'd rather do carry bits and stuff like that. All right, so we're going to go ahead and we're going to add 1 to this guy. So just to make this a little bit more generic, let's write a function here called well, actually, because of the way we're doing this here, I don't necessarily want to make another function. All right, so we'll just add 1 to this guy. So we're going to have a int carry, and that guy will start off at 0 because we're not going to have any carry at the beginning. All right, and we're going to walk from the end of our binary array towards the beginning of it. So we're going to say, I already have an I in here, right? Yeah. So we'll say for I is equal to bits minus 1. So that's the last legal bucket. I is greater than or equal to 0. I minus minus. So we'll walk from the end of the array towards the front of the array. And each time through, what are we going to do? We're going to take the, we're adding a 1 to it. So actually what I need to do before this, if we're going to be completely legit with this, is I'm going to pad an entire thing up with zeros equal to the number of bits, and then throw a 1 in the far right thing. All right, so I'll go ahead and you mentioned memcopy, right? Yeah. Here, let me just do a man page on that real quick. CPY, right? All right, so that is in string.h. That's weird. Why is it in string.h? So I would give it the address of a 0.
No, what do you want to do?
I want to copy zeros in here. This isn't going to be good
Zero
for.
and just one. Just want to do 0, copy 0.
Yeah.
You can do memset.
Fill an array with bytes. Okay, and this is in. That's also in string H.
Yeah.
That's weird that it's in there. Okay, so this will be my array. Here's the value, and this is the number. This is the size. So I'll pass it the pointer to my array. I'll pass it 0, and I'll pass it bits. And I need to include string.h. It almost seems easier to just write the for loop. All right, so to go our 2's complement, we're going to get our, we're going to have our int pointer. Let's just call it 1. Int pointer 1, that's going to be malloc bits. And then we're going to say memset. Memset, and we're going to pass this guy the pointer to my array, which is 1. We're going to pass it the value we want to fill it, and we're going to tell it that it is the size of it is bits. And that should fill it up with zeros. See, I don't trust that since we're using integers here. Yeah. I'm just going to write it so it's right. Yeah. That's why I was wondering, why is it in string? Okay, so for I is equal to 0, I is less than bits, I plus plus, we'll say the value of 1 plus I is equal to 0. So we'll go ahead and fill it up with a bunch of zeros. And then the very last thing we'll say is we're going to say the value at 1 plus bits minus 1 is equal to 1. So that'll give me a binary version of 1. That's bits wide. That make sense? All right, so now I'm going to add whatever is in AR. Actually, no, whatever is in answer, because we already filled it up with the 1's complement. So we're going to add whatever's in answer to our whatever's in 1, which would just be a whole bunch of zeros followed by 1. And we have our carry bit there. So we're going to walk from the end. So bits, because answer and 1 are the exact same width. They're in the exact same bit space. So if they both have 32 bits or something like that, I should be able to walk from the end towards the beginning and do the addition there. So we're going to say that, think about the carry, because I can overwrite answer with this. So we're going to say the value at answer plus I is going to be equal to, so now we need to do the answer at bucket I plus 1 at bucket I plus carry, and determine what the carry bit is. All right, so let's actually do this in 2 steps. We'll say int temp. So we'll say temp is equal to the value answer plus I plus the value 1 plus I plus carry. Like that. So that's going to get us a value in temp. If temp is greater than 1, okay, if temp is greater than 1, that means it's a 2. Okay, or it could be a 3 actually, because we have two different carry bits. So actually, let's just be explicit so we play it out. If temp is equal to 3, then we're going to set carry equal to 1. And we're going to set temp equal to 1. Else if temp is equal to 2, carry will equal 1, temp will equal 0.
How can it equal 3?
1 plus 1 plus 1. If we already have a carry of 1. So you have 1 in both places plus a carry, you're going to get a 3.
Okay.
So that's a 1 plus a carry. All right, so if it's a 3, we have a carry bit and an answer of 1. If it's a 2, we have a carry bit and an answer of 0. Otherwise, temp is just what it is, and we have no carry. So else carry is equal to 0, just in case we had a leftover carry from the previous thing. Okay, so after this, temp and carry should be the correct value. So we'll say the value at at answer plus I is equal to temp, because that's going to be my final bit there, and carry should be appropriately set for the next spin through for this for loop. That makes sense? Okay, now we could run into a situation here. I mean, this will do the math now, but we could run into an overflow bit issue if we get all the way to the left and we didn't think about the size of it. So if we come out of this loop here, I'll just do a print statement. So I'm going to say check for overflow. We're going to give it input that's correct input, but just to show that it can happen, we're going to say if carry is greater than 0, it would only ever be a 1. Then we'll do a printf, call this guy carry overflow. Something like that. Okay. Now this guy is going to return an int pointer, so my answer should be inside of answer, because I built it up inside of answer. So I used answer to get part of my answer, and then I overwrote answer with the 2's complement value. So I did it in place. Okay, so let's go back in here. If our value is less than 0, get the original value of it. So multiply by -1. Get the 2's complement of this guy. And then let's say int pointer 2s is equal to, what do I call it? Binary to 2's. Binary to 2's complement. And this guy takes in answer, and he'll take in bits. So that'll be my 2's complement version of that guy. So we'll go ahead and do a print array passing an answer, and we'll do a print. Actually, we can do a we'll do a print array 2s, and we should be able to see that. Okay, so using some of our sample values here, so we go to our 2's complement, let's go ahead and let's represent a 7 in 4 bits. And we should get a 0, 1, 1, 1. Oh. Oh, I can't name a variable starting with a 2. It was called 2's like that. All right, implicit. Yeah, very interesting. Why is it all of a sudden making me prototype them when it didn't earlier? We also have print array. Oh, print array requires number of bits too. All right, so we'll do a 7. How many bits? We'll say 4, so there's my 0, 1, 1, 1. And then let's look at -7 in 4 bits. Should be 1, 0, 0, 1. -7 in 4 bits is 1, 0, 0, 1. Let's see if it works for several other ones. Let's do our -8 since that's kind of our special case. Not really a special case, but the math should still work. -8, 4 bits, that's 1, 0, 0, 0. -2, 1, 1, 1, 0. -2, 4 bits, 1, 1, 1, 0. What if I say -2 in 16 bits? That is weird. So it didn't like my malloc when I said 16 bits. So that probably went into decimal to binary initially. Filled it up with zeros. That should have been fine. I'll just run that again real quick. What is he not happy about? I don't see why that's wrong. Well, without taking it into a debugger, let's see if I can at least determine where is the problem. Just comment that out for a second. Make sure it's in decimal to binary is where I suspect it is. So get rid of that. -2, 16. Oh, no, it's not in there. So it is in 2's complement. -2, 16. Okay, so it is in 2's complement. Does answer have enough bits in it? It should. Let me do a print array answer and bits. -2, 16. Oh, okay. So the problem is it is in decimal to binary, but it has to do with the answer that's coming out of there. Decimal binary, int pointer answer, malloc bits, so that gives us enough bits. Then we go through everything in answer and fill it up with zeros. That should work. Because then I passed it to print array. So I mean, it's failing right here. -2, 16 bits. Okay, hold on. No, it's fine there then. So that is 2 is 16 bits. Then if I want to get the 2's complement of that, -2, 16, okay, that's where it's failing. So this should give me some memory. Now it is screaming at malloc. So this goes through and it fills it up with zeros or ones. That should work. I'm grabbing more memory here. Malloc should work for that. Setting it to zeros. Then I'm setting the 1 memory location to 1. That's base address of 1 plus bits minus 1 should give me the last legal position. But it's one of those 2 mallocs that's breaking. Here, just as a point of interest, let me copy this into my terminal. Okay. Well, because all these, if we do add 1 to this, this is all a bunch of 1s, and this is 0, this is 1. So 1 plus 1 is a 1 with a carry. Actually, they wouldn't have a carry in that case. So if this is the binary equivalent, I flip all the 1s, all the 0s to 1s. This becomes a 0, this becomes a 1. I add 1 to it. 1 plus 1 is a 0, carry a 1. 1 plus 0 is a 1. All these other guys stay zeros. So then why is my carry overflow flagging, and why doesn't this guy have a bunch of ones in it? Something, but it also is interesting that it runs on here. It doesn't crash. All right, let's look at my 2's complement again. Brand new memory answer. Fill it up with, so I'm going to go through every bucket of that guy. I is 0, I is less than bits, I plus plus. I'm going to look at the current value of AR, which is the value that was passed in. And I'm going to say if that guy is equal to 1, then set answer at the same position equal to 0. Else set answer at the same position equal to 1. All right, that should successfully fill answer with the 1's complement of AR. Two's complement, we get an array of the exact same size. We go through, we fill it up with zeros. Name of the array is 1. Value at 1 plus I is going to be 0. That should fill it with zeros. Then I'm saying the value at base address 1 plus bits minus 1, which should be the last legal position in that guy, is going to equal 1. That gives me, in this case, the 16-bit version of 1. Set my carry to 0. Give myself my temp. Start at the end of my array, so that's the last legal position, bits minus 1. Keep going as long as I is greater than or equal to 0, because I want to include bucket 0, I minus minus. Very first thing I'll do is I'll say temp is equal to the current bucket in answer plus the current bucket in 1 plus whatever carry is. If temp was equal to a 3, we're going to have a carry bit, and temp is also going to be a 1, because that's going to be the value I'm going to add. Else if temp is equal to 2, we'll still have a carry bit, and temp will be equal to 0. Else temp must have been either a 0 or a 1, therefore we will 0 out our carry bit. And then we'll set answer at bucket I equal to temp. Go ahead.
Temp equals answer I plus 1 plus I plus carry. Wouldn't it then necessarily be jumping over like extra slots, or is it still going to every?
No, because this is give me bucket I from answer, plus give me bucket I from 1, plus give me carry. This is just doing a math problem.
Oh,
So I'm just saying
okay.
set the variable temp equal to the sum of those three things.
Gotcha.
2, carry, else carry 0. Overwrite answer at bucket I. We're still in the loop with the value of temp. Okay. And we are changing carry whenever we're done with something. When we come out of here, we're asking the question if carry is greater than 0, then we're printing out a carry overflow. So that means that since we're seeing carry overflow, carry is greater than 0 at some point and when this guy's bailing out. So I starts at bits minus 1. I is greater than or equal to 0. I minus minus. So that's the last legal bucket in answer plus the last legal bucket in 1. I assume those two are the same size. Answer and 1 are both bits in length. Plus the carry, which started off as 0, and then we flip it as necessary in here. I don't see anything wrong with this. I don't need to tell Malik that I'm creating an integer pointer, do I?
It's not manual.
It says it's carry, like you said carry overflow. You got that triggered twice. So wouldn't that be saying that?
Well, it would only trigger at the end of it one time. So that means carry is greater than 0. The only way carry can be greater than 0 is if we got an answer, if we got a temp that was either 3 or a 2. There, we could do this. We can do a little printf %d, maybe throw a space after it, and print out temp as we're going through there.
Yeah.
Oh, I very rarely spell printf correctly the first time. -2, 16. Let's see if we got some output. Yeah, so this was temp. Actually, no, that's not temp. Here, I need to bring this into my program since I'm not getting any output in here. All right, so we got a here, just for the sake of, since we have the function, I'm going to call print array on my ones complement. -2, 16. All right, so we are doing something bad with memory here.
Do you have Mandarin?
Do I have who?
Mandarin.
Because it died right here after I got my ones complement. It couldn't print that out. I mean, surely this variable answer here and this variable answer here are in very different scopes. They should not be conflicting with each other.
between two digits.
Well, that's why I'm thinking that this needs to be int pointers. Just at least try that for these mallocs. Should not be incorrect to say I want you to give me an int pointer rather than a void pointer. Okay, let's at least try that. That was the problem. See, so it's your fault. It's like, oh, we don't need all that. I think he might have said that after the fact. Yeah, so, and well, actually, so now let's copy it back over because now we have very different values in here. So I'm going to come up here. So traditionally, when I create new memory, I say I want an integer pointer. Otherwise, it comes out as a void pointer by default. But it seemed like this thing was letting everything else be more modern, so wouldn't it just treat the pointers the way they need to be treated? So I'm going to change these all to int pointers. Because I really think those are related to each other. When you say int pointer here, and then you say plus I here, that dictates the size of the step it takes. I think those are all my mallocs.
Like pointer char, it would take a different size step.
Yeah, because then it would take 1 byte steps instead of 4 byte steps. But it's interesting, this guy's still giving, we're getting a different problem here versus, so if this was my, oh, hold on. Oh, wait, this is the value for my carry. This should be, yeah, they should be, that should be the ones complement. So I'm going to print out the decimal version of that. That's correct. Then I'm going to go to binaries to 2's complement. So that should just get me my 1's complement there. And if we just stop it, so that's the 2. That's the inverse of that. So the 1's complement is working, right? You know what I bet? Is it that I don't know why that would be a problem. But is it that I'm overwriting answer in itself? So when I get the 2's complement here, I'm creating my 1. That should give me my correct number of bits for my 1 there. And actually what I can do is I'll go ahead and let's just do a print array for that. Let's just make sure I have 15 zeros followed by a 1. Print array 1 and bits. Yep, so that looks legit, right? Bunch of zeros followed by the 1. All right, so I have my carry here. I wonder if the problem, so I'm reading in the value from answer here. I'm printing out my value of temp there. But right here, I'm overwriting answer with temp. That really shouldn't be a problem, but it seems like that's the only thing that could be breaking. So if I really, here I can just do this then. This will be just a quick way of testing and see if that's the problem. So I'll create an int pointer. Answer 2 is equal to the integer pointer version of malloc bits. And then down here, rather than overwrite answer, I'll overwrite answer 2 with whatever's in temp. And then I'll return answer 2, which should be my final answer. So that's a negative number. That, I think that's the encoded version of 2. If we do this again real quick. If I do -7 and I do it as 4 bits, I get the 1001. All right, so that seems to be the reason. So then, so then the question is, why couldn't I change the value of yeah, and see, this still gives us a an error in here dealing with malloc. It's very interesting. All right, well, since I'm not giving you a good starting point here, we'll just do a fun exercise for our homework. Figure out what's wrong with that. Let me give you the next reading assignment too. So you might solve this in 5 minutes, or you might spend a week on this. I mean, we have it running on the other thing, and it seems to be fine, but I wonder what the problem is there. It's got to be something weird with memory. So let's see. We just did signed and unsigned. So let's do... So go ahead and read 2.4, which we've already talked about, but do go through the exercises for there and do 2.5 and 2.6 and 2.7. So everything but not procedures. So 2.4 through 2.7, complete all the exercises there. And then I'll put that up on Blackboard so you can submit screenshots and get points. And then the second part of it is I'll post my current code up to Slack. It seems to work on my computer, does not seem to work online for that thing. Figure out why. It's probably going to tell us something about what that website, how that website works, whatever the bug is. Why is this broken on website? So, oh well. Interesting while it lasted. But it is weird that I can get it working now on my machine with the current version. So it's got to be something weird with memory. Okay, so I guess shorter homework assignment, more reading, less programming, and I'll see everybody next Thursday.